All right, so we're going to continue with linears today. And today we're going to be taking a look at x and y intercepts. Okay, x and y intercepts. So the y-intercept is pretty powerful because it is on the y-axis, and it's where we start. Okay, so any place on that y-axis, that's going to be our first point. Our x-axis, obviously, is our horizontal, so we're going to be looking at where they cross the x and y-axis. Now, when we are looking at x and y intercepts, there's a lot of context in story problems that look at x and y intercepts. We're going to take a look at that today also. But before we start that, we're going to practice again solving to standard form. Okay, solving to standard form, because if we are in standard form, solving for the x and y intercepts is simple. It is simple, because we're literally a substitution, and it's a one-step equation. Okay, substitution and one-step equation. So super important that we can actually solve to standard form. So why don't you take a second and write down what standard form is for me, and then what is slope-intercept form. Okay, so hopefully you remembered standard form is ax plus by equals c, where a, b, and c are numbers. And the rules were no fractions, and a has to be positive. Now, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. Okay? B is the y-intercept. All right. So go ahead and hit pause. And why don't you go ahead and start with this one, the one on the right. See if you can get that to standard form. Okay, standard form. So we need ax plus by equals c. And then we'll do the fraction one together, because that one's going to be a little bit more challenging. Okay, let's see how you did. So I'm going to go ahead and start on this first one. And I'm going to go ahead and do my distribution, because I know that I can't have any parentheses when I need standard form. So 3 times 2 is 6x. 3 times negative 4 is negative 12. Negative 3 times 2 is negative 6y. Negative 3 times 8 is negative 24. Okay, so I need y equals, or sorry, I need ax plus by. So I need to get this guy to the other side and that one over there. So if I move the 6y, I'm going to be adding it. Okay, I'm going to be adding 6y. So 6x, 6y, the minus 12, the negative 24. I also need to add the 12 to move it to the other side. So this is gone. So 6x, 6y, and a 12. So now I can clearly see what my A is, what my B is, and what my C is. So A is 6, B is 6, and C is 12. Okay, good job. Okay, now let's take a look at this next one, because this next one's a little bit more challenging. All right. How are we going to clear that fraction? What is my least common denominator with 2 and 9? 2 and 9. If you're thinking 18, you're right. Okay, you are right. So we need to go ahead and do that multiplication. So we're going to be doing times 18, times 18, times 18. And this is really calculator work. Okay, so I'm going to actually flip slides here. So I have 5 times 18 divided by 9. So I'm going to go to my Desmos. 5 times 18 divided by 9. And I get a 10. Okay, I get a 10. So go ahead and hit pause and see what you can do with clearing the rest of those fractions. Okay, let's see how you did here. So if I take 3 times 18, I get 54. So negative 7 times 18 divided by 2 is going to give me a negative 63. And this one's pretty simple to finish solving because all I have to do is move that 54y. So 10x minus 54y equals a negative 63. And there's my A, there's my B, there's my C. And A is positive on all of these, so I don't have to worry about changing the sign by multiplying by a negative 1 at this point because everything is positive. It's good to go. Okay, it's good to go. Okay, so again, standard form is essential when we're finding x and y intercepts. Okay, and just to make sure that you remember what an x-intercept is and a y-intercept is, this is our y-axis, our vertical, okay? The y-intercept is where it crosses that y-axis. And notice how that number right there is a 0, okay? If I was to put a point right here, this point would be 0, 9, and the point down here would be 0, negative 3. So every point on the y-axis has a 0 in the x value, okay, in the x value, every single one of them. And the same thing holds true when I'm looking at the x-intercept. So the x-intercept is where it crosses the y-axis, or the x-axis, okay, the horizontal. So if I take a look at this ordered pair, this is negative 4, 0. Notice that the 0 is in the y value. Okay, it's in the y value. So this point right here would be 2, 0. Now those zeros are really important because that is where our substitution is going to come in. Okay, we're going to be using those zeros. Okay, now before we get started, I want to take a look at a scenario just so that you can kind of understand where we might actually see x and y intercepts applied in real life. Okay, so we have a swimming pool that's being drained, which means it's being emptied. The water's going out of it at a rate of 720 gallons per hour. The table shows the function relating to the volume of the water in a pool and the time and hours the pool's been draining. So here's my table. Okay, and here is my graph, and I have a y-intercept here, and I have an x-intercept here. Okay, so I want you to take a minute and see if you can find the y-intercepts and the x-intercepts up in the table. Where are the x-intercepts and y-intercepts in the table? Okay, hopefully you found them right there. And what we notice is that we're looking for the zeros. Okay, we're looking for the zeros. So here's my y-intercept. Here's my x-intercept. My y-intercept and my x-intercept. Anytime I see a 0 in either x or y, that is going to be an intercept, which is an important value for us. Okay? Okay, so now I want you to think about what the y-intercept means. Okay? So what does the 0, 10,000, 80 mean? Remember, we're talking about a pool. Okay, if you said to yourself, the pool is full, that's my starting point, okay? I have not drained any water in it. So the pool is full with 10,080 gallons of water. That's what we're starting with. So the pool is full, okay? Now, I'm going to start to drain the pool. So what does the 14, 0 mean? What does the 14, 0 mean? What does this point mean? Now remember, this is time, okay? This is time. So 14, 0, think about that for a second. This is time. This is hours. What unit is the 0? You're right, that's gallons. So that means the pool is empty because there's 0 gallons. And it took how long? It took 14 hours to empty the pool. Okay, it took 14 hours to empty the pool. So we are definitely going to be using X and Y intercepts in context, okay? Because there's a starting point where you have something that is full or a total amount of something, and then it's going to be increasing or decreasing, and something else is going to change to where it ends, okay? Something else is going to change where it ends. So X and Y intercepts are pretty powerful. Okay, let's actually get into the algebraic part of finding X and Y intercepts. Okay, so remember, we need to be in standard form. That's the first step. So no matter what, get them to standard form. And then it's really substitute and solve. Okay, substitute and solve. So we already know that on an x-intercept, the ordered pair is x comma 0. Okay, so remember, we're talking about a line. So like this ordered pair is 3 comma 0. That is a 0. Okay, so what happens is I am actually substituting in a 0 for y. Okay, a 0 for y. I'm going to let y equal 0 because no matter what, it does not change. And this ends up going away. So I'm left with 2x equals 12, which means x equals 6. Okay, x equals 6. So that ordered pair is 6 comma 0. 6 comma 0. And I know this is 0 because it is an x-intercept and y is 0. It is the same thing on the y-intercept, except for we're substituting in for the x. Okay, so I have 2 times 0 plus 3y equals 12, and that goes away. So I'm left with 3y equals 12, so y is 4. So that ordered pair is 0, 4. 0, 4. So if I was to graph that, 1, 2, 3, 4, 5, 6, there's my x-intercept. 1, 2, 3, 4, there's my y-intercept. There's my line. Okay, so here is another one. Keep in mind this is not in standard form, so we're going to have to make sure and get it to standard form first, and then we'll go ahead and find the x and y intercepts, and then go ahead and graph it. So if you feel like you're ready, go ahead and hit pause and solve it to standard form, substitute in for your x and y intercepts, and go ahead and draw yourself a quick graph. All right, so let's put this in standard form. So I know standard form is ax plus by equals c, which means I need to flip-flop these two. And remember, when I cross that equal sign, the signs change. So I'm going to be adding the 5y, and I'm going to be adding the 15. So I end up with a negative 3x plus 5y equals 15. And I'm not going to worry too much about a being negative right now. That's kind of irrelevant for what we're doing here, okay? Because no matter what, if I change it to a being positive, I'm still going to get the same answer. So if you want to change it, change it. If you don't, that's just fine on this one. Now remember, on an x-intercept, y is 0. Okay, so negative 3x, there's my 0 and my 15, so that's going to go away. Negative 3x equals 15, so x equals negative 5. So that ordered pair is negative 5, 0. So negative 5, 0 is going to put me to the left. All right, on your y-intercept, x is 0. And for some of you, I'm sure you've gone, well, can't I just like leave off the x because it's going to go away? Absolutely. What I'm really looking at is, I'm going to go ahead and write this again just so I can kind of show you a shortcut. What I'm really looking at is that this is going away. So I don't even need to write it. I'm really looking at 5y equals 15. And I know that if 5y equals 15, then y is 3. So that ordered pair is 0, 3. And we always write x and y intercepts as ordered pairs. We don't just leave them as x equals 0 or x equals 5 or x equals 3 because that is either a horizontal or vertical line. So they need to be written as ordered pair. So 0, 3 is right there. And my line is a positive slope. That's not a very good line. Positive slope going up. All right, so today you're going to be working on practicing those x and y intercepts, finding them from a variety of equations. So remember, take them to standard form first and then substitute and solve. And I will catch up with you tomorrow when we take a look at more applications of x and y intercepts.